Auzu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. Welcome to Analog Design Electronics Series. I am your instructor for this course and welcome all of you. Analog design involves both art and science at the same time. It classifies as art due to it need imagination to get the optimal outcome agreement among the required specification and the formatter. It is also a science discipline since it requires certain degree of approaches for execution of the design and our unavoidability resulting in greater understanding of the limitation of it. This course serves as a introduction guideline. We have this remarkable combination of both art and science. This course will equip you with several fundamental components of analog design. The topics covered in this course are listed here, where MOSFET and BJT modeling. In this chapter, we will cover the mathematical and graphical representation of MOSFET and BJT devices to predict their electrical behavior in certain circuits. In another chapter, we will consider amplifier as an electronic device that increases the amplitude of a signal, enabling it to drive load or transmit over distance under the given conditions. Then we discuss about source followers. Source followers is a common source MOSFET amplifier configuration that provides voltage buffering with high input impedance and low output impedance. Then we discuss about cascade amplifiers. Cascade amplifiers involves connecting multiple amplifier stages to increase the overall gain while managing bandwidth and stability. We pay a lot of attention to the ultimate device of the output of the signal. Then we discuss about device performance. In this chapter, we will examine the importance of impact of the noise on electronic circuits, focusing on minimizing unwanted signals to improve performance and signal integrity. Then we discuss about the stability of analog circuits. Stability in analog circuit refers the ability of the circuit to maintain consistent behavior without oscillation or unwanted variation under varying conditions. Then we discuss about differential amplifiers. Differential amplifiers amplify the differences between the two input signal while rejecting a common mode noise, making them highly suitable in various applications. Then we discuss about design of multi-stage operational amplifier. This topic involves the design principle of multi-stage operational amplifier to optimize performance parameters such as gain, bandwidth, and noise. Then we discuss about class AB and driver amplifiers. Class AB amplifiers combine the advantages of class A and class B design, offering high efficiency and linearity, while driver amplifiers provide the necessary power to drive the output stage. Transconductors amplifier. A transconductor amplifier converts input voltage to the output current, providing gain and linearity in applications such as analog signal processing. Then we discuss about filter design. Filter design focus on creating certain circuits that selectively allow certain frequency component of a signal to pass while attenuating others. And at last, we will cover analog to digital converter and digital to analog converter circuits. This topic involved the principle of analog to digital converter and digital to analog converter circuit, which facilitate the conversion between analog and digital signal. As all design in analog is about circuit, and all circuits contain transistors. Mathematical models are essential for these devices in order to be able to predict the circuit performance. CAD tools such as SPICE, Aldo, and other computer-aided design tools are then used to verify the predicted performance. This feedback loop is essential to converge to a real design. This loop will be used continuously to design analog IC. For the design of analog circuit and particularly analog integrated circuit, we need to be able to predict the performance, ultimate performance of the circuit by the need of some expression, mathematical expression. We try our best to convert these complex into approximately simple expressions. As a result, simple models are required. This means that the small signal operation of each transistor must be described by as few equations as much as possible. So some approximations are involved. And these approximations create some deviation from the real behavior of the circuit. Clearly, the performance of the circuit can then only be described in an approximate way. The main advantage, however, is that transistor sizing and current level can easily be derived from such simple expression. They can then be used to simulate the circuit performance by means of conventional circuit simulators such as SPICE or LTSPICE circuit. In these simulators, models are used which are much more accurate but also much more reliable and complicated. These simulations are required afterward to verify the circuit performance. The initial design with simple model is the first step in the designing procedure, and they are aimed indeed at the determination for all transistor current and sizes according to the specification. In chapter 1, we will discuss about the modeling of metal oxide semiconductor transistor and BJT. We start with metal oxide semiconductor transistors devices in chapter 1. Then we discuss about bipolar transistor and then we, we study the number of the MOS transistor integrated on chip as a bipolar one. Thank you.